Good afternoon. I welcome you to this session of IC engine and gas turbine. As I said that in this course IC engine part will be discussed by me and gas turbine part will be discussed by Professor Vinayak Kulkarni. I have divided the course content of IC engine through different modules, and these are the different modules, rather week-wise modules, and the topics that I will be discussing through different lectures. So, today we will be discussing about the internal combustion engine, different parts of internal combustion engine, and then we will discuss about engine classification, and we will be discussing about the difference between the external and internal combustion engine. So, as the name suggests, this is internal combustion engine, that is the combustion takes place internally, and we will be discussing the combustion process in one of my lectures, but combustion is nothing but the appearance of flame and from which you are getting heat, and that heat is used to increase the temperature and pressure of the working fluid of the engine in the engine cylinder. Now, while we talk about internal combustion engine, the combustion takes place internally and the heat which is being generated because of the combustion, that is used to increase the temperature as well as pressure of the working substance. We will see that working substance is essentially fuel air mixture, or which is known as charge, and we will see that there are different strokes because of the combustion. The high pressure, high temperature is of the working fluid is developed, and different strokes are executed by this process. Now, mostly we will be discussing about different components, different thermodynamic processes, as well as the geometric, rather different geometric, different components. In particular, the operational principle of the engine and operational principle of different components that is there in internal combustion engine. So, this is basically this course is for internal combustion engine. So, the different modules will be discussed focusing on the internal combustion engine, but now we know, at least we should know what is the difference between external combustion engine and the internal combustion engine. Now, external combustion, that means the working substance of the fluid or engine. In case of an external engine, the working substance is heated, of course by the combustion process, but the combustion process takes place externally, and the temperature which is being developed because of the combustion process will be supplied to the working substance of the engine through the engine wall, but the combustion does not take place within the engine cylinder. So, in case of a external combustion engine, working fluid is heated, rather the temperature of the working substance, working fluid is increased through the combustion process certainly, but the combustion takes place externally, while the developed temperature because of the combustion is supplied to the working substance of the engine through the engine wall, while in case of an internal combustion engine, the temperature and pressure developed of the working substance, rather charge because of the internal combustion. Now, we will see what are the different components of an internal combustion engine, and we will try to specify their functionalities. So, in particular we will try to describe different components through a schematic diagram. So, now I am trying to draw the schematic depiction of that engine in a generic way, and from there we will try to figure out that if I try to classify engine based on two different criterion that we will discuss, then what are the components will be there for any particular engine and what are the components won't be there for other type of engine. In fact, I can write nomenclature of IC engine. So, this is basically you know the schematic depiction we will try to see different parts after this description is complete. And I will try to label every components. So, now we will try to see rather what are the, in fact I have drawn the schematic, and now I will try to label different parts. So, this is known as carburetor. So, this is carburetor. We will see that this part is essential for one type of engine and this is not required for other type of engine, and this is supply line. So, this is air supply line and this is fuel supply line, and this special item which is known as spark plug, and this is spark plug, and this is known as exhaust manifold. Similarly, this part is intake manifold, this part, and this part is known as rocker arm, and the piston movement within the engine cylinder is restricted between two stops. The first one is which is close to the intake and exhaust manifold, which is known as top dead center. In many books it is written inner dead center or IDC. So, TDC or IDC they are equal, and another stop which is at the bottom of the engine cylinder, and that is known as bottom dead center, or in many books it is written ODC, outer dead center. And this is crank and connecting rod mechanism, and we can see this is oil pan. This is oil pan, it contains lubricating oil. Now, the objective of providing this oil pan is to provide lubrication to the engine, to the valve, because the piston movement is continuous. Now, we need to provide lubricate, rather we need to supply lubrication, proper lubrication. We will discuss in one of my lectures that what are the different types of lubrication we can have, and rather lubrication system in detail. Now, as a result of rotation of the crankshaft, the lubricating oil is supplied to the wall of the engine cylinder, and by by means of oil churning. Now, we can see that there are two different valves. Of course, the valve which is connected with the intake manifold, that is intake valve, and the valve which is connected to the exhaust manifold, that is the exhaust valve. Now, the normal tendency valve is spring loaded. We can see this is spring, this is spring, and this is cam follower, this is cam, this is cam follower, and this is known as push rod. Push rod, and this push rod is connected to rocker arm. Now, since the spring is there, rather due to the presence of spring, normal tendency of the valve will be to remain closed. Now, when the piston is moving up and down, now because of the cam and follower mechanism, the intake valve opening can be controlled through the rocker arm. Two important components are the carburetor and another is the spark plug, and also this is piston and this is piston ring. And this is engine cylinder. So, now after completion of labeling different parts of the engine, we can now discuss their function. Now, the carburetor is provided. This part may not be there in a particular type of engine, but carburetor is provided to supply a homogeneous mixture of fuel and air. So, what we can see from the schematic that the fuel and air line, both the lines are connected to the carburetor. Now, carburetor allows homogeneous mixture of the air and fuel, and that homogeneous mixture of the fuel and air is supplied to the engine through the intake manifold. And exhaust manifold is important because after the combustion process, all the exhaust product will leave from the engine cylinder through this manifold to the ambience. Now, this exhaust manifold is also having one valve, exhaust valve, and the valve is also controlled through this kind of mechanism. Now, another important part is the spark plug. The function of the spark plug is to provide, rather to initiate spark, and that is very important only for the spark ignition engine, that we will see. And piston is moving between two stops, one is top dead center and another is the bottom dead center. So, the movement is restricted between these two centers. Now, piston is having piston rings. Now, piston rings are provided essentially to prevent piston, because piston movement is continuous. So, if we do not provide piston rings, then there will be a direct contact between piston and this wall of the cylinder. Now, because of this continuous movement, there will be a frictional effect. So, to essentially to prevent, rather to increase the piston life, the piston rings are provided. So, what we can see from this figure, that the frictional effect that will be there with the piston ring only. At the same time, the piston ring should be the should allow no leakage of the combustion product, otherwise the pressure which is being developed at the end of the combustion product will fall. So, this is the nomenclature of an internal combustion engine. One thing which is important to note, that this is specifically the nomenclature of a spark ignition internal combustion engine. Rather, this is, I can say that this is for the spark ignition. We will discuss what is spark ignition. Spark ignition or SI engine, and another is known as compression ignition. So, this is the nomenclature, or rather the different parts labeled here are the components of a spark ignition engine, but this will be the schematic diagram, rather I can say all the parts will be there even for a CI engine, that is compression ignition engine, except two parts, that is the carburetor and the spark plug. So, carburetor is not there in a compression ignition engine, and the spark plug will be replaced by another component, that is nozzle. So, if I talk about the nomenclature of a compression ignition engine, this will be the schematic depiction, except two different parts, the carburetor will not be there and the spark plug will be replaced by another component, that is the fuel nozzle. And in this context, I will discuss that the carburetor is nowadays almost obsolete. It is not an essential part of the engine, but we should know that this particular component is having important function, and there are a few objectives of designing this modern carburetor which are used, but again I am saying that nowadays this is not an essential part of the even for the SI engine system. So, we have understood that the functions of different components of internal combustion engine. If it is spark ignition engine, then this is the schematic depiction. If it is the compression ignition engine, then the spark plug will be replaced by a fuel nozzle and the carburetor part won't be there. Instead, we will take fuel through the fuel nozzle and airs will be introduced into the engine cylinder through the intake manifold. So, with this, next we move to see that how the internal combustion engine can be classified. So, when we talk about internal combustion engine, in the last slide just I have introduced two different words, one is spark ignition engine, that is SI engine, another is the compression ignition engine, that is the CI engine. Now, this is a kind of classification, because when I talk about spark ignition engine and compression ignition engine, so it is a classification, and this classification is based on the types of combustion. So, when we talk about classification of internal combustion engine, then IC engine can be classified based on two important factors. One is the classification of IC engine. So, number 1 is IC engine can be classified based on the types of engine, that is what I have written in my last slide, that is types of combustion. So, it is spark ignition and compression ignition. Now, when we talk about classification based on the types of combustion, then SI and CI, these two are the classification. Now, so this is SI and this is CI. Spark ignition engine, that is spark plug is there and this external agent is essential component for this type of engine and this is used to initiate spark. We will discuss in detail again what the requirement of having spark plug and how we can create a spark. In fact, the spark is used to break a huge resistance. So, the spark ignition engine means spark plug is there and the spark plug is used, this external agent, rather external component is used to initiate spark and that spark is used to initiate combustion in the engine cylinder. So, by igniting, rather by switching on the spark plug, we can ignite the combustion mixture, rather charge in the engine cylinder and entire process of combustion is initiated by switching on the spark plug through the generation of spark. If we do not generate spark, combustion won't takes place. So, here combustion takes place through the initiation of spark and for that the external agent spark plug is there. Now, for compression ignition engine, as I said that this external agent won't be there, rather we will have a fuel nozzle and this fuel nozzle is used to supply fuel and again since the fuel is supplied through fuel nozzle, rather fuel will be supplied through the fuel nozzle and air will be taken through the intake manifold to the cylinder, we need not to have carburetor. Now, this compression ignition engine, since we do not have, rather we do not require any external agent like spark plug, the combustion will be initiated by the temperature and pressure which is developed at the end of the compression stroke of the engine and again we will discuss. So, for the time being we should know for the compression ignition engine, the compression process itself initiate the combustion of the charge in the engine cylinder, while in case of SI engine compression is not sufficient to initiate combustion and we need to provide a spark externally and that is why the spark plug is there. So, this classification is complete. Now, number 2, that is important to know that again we can classify engine based on the number of strokes. So, classification based on the number of strokes. And again based on the number of strokes we can classify engine into two different classes. Number 1 is the 2-stroke engine, and 4-stroke engine. Again we know that 2-stroke engine is very difficult even today because nowadays no engine is 2-stroke, all engines are 4-stroke engine. In a 2-stroke engine the entire operation starting from intake of the charge, rather intake of fuel and air to removal of all the combustion product from the engine cylinder takes place, rather executed by 2 different strokes and that is why it is 2-stroke, while in case of a 4-stroke engine entire process or rather engine operation, starting from induction of fuel and air into the cylinder till the removal of combustion product from the engine cylinder takes place through 4 different processes, rather 4 different strokes, that is why it is 4 stroke. I should say in a 2 stroke engine, that is very important that only one revolution of the crank per cycle, while in case of a 4 stroke engine we will have 2 revolution of crank per cycle. Per cycle. Since it is 2 stroke engine, per cycle mean, again I am telling, because as I said that to complete the entire operation we need 1 cycle. So, starting from induction of fuel and air to the cylinder, then compression and ultimately the then combustion, ultimately combustion product will go out from the cylinder. So, entire process is completed and entire process is known as 1 cycle. Now, for this cycle there is only 1 revolution of the crank, but in case of a 4 stroke engine, for that particular cycle we will have 2 revolution of the crank, and this is very important in the context of engine operation, because since we are having 2 revolution of the crank. So, we will discuss in detail that there are a few advantageous features which is not there in a 2 stroke engine. Again we need to know that we can classify engine, spark ignition engine, CI engine, and then number of strokes. So, we will write in details, but at least for the timing we should know that what are the different 4 strokes in a 4 stroke engine and what are the different 2 strokes in a 2 stroke engine. So, now if I try to write that how we can rather if we talk about the 2 stroke and 4 stroke engine, then because of the number of strokes we are classifying, but when we talked about types of combustion, just we have understood that the combustion process is initiated by the spark plug in case of SI engine, but the compression process itself is responsible to initiate the combustion process in a compression ignition engine. So, we need to know what are the fundamental differences between the SI and CI engine. So, now we will try to know fundamental differences between SI and CI engine. So, what are the fundamental differences? Now, number 1 is the basic cycle. So, if I write SI and if we write CI over here, then if we try to find out the fundamental difference between these 2 engine based on the basic cycle, then what is the difference? As I said, cycle is that time required to complete the entire operation, that is the cycle. Now, the SI engine in general is based on the Otto cycle that we will discuss. In general SI engines are based on Otto cycle, where the basic cycle of operation, rather I can say when we talk about a cyclic operation of the engine, the cyclic operation of the engine is basically intake, then combustion, then removal of combustion product. So, when we talk about intake, combustion, then removal of combustion product. So, within the engine cylinder, the combustion product, rather working substance will be changing continuously, rather the thermodynamic properties of the combustion product, rather charge working substance will be changing continuously. So, at least we need to map the change of thermodynamic properties of the working substance when they are taken into the cylinder, and eventually they are the charge is taking part in the combustion is there in the cylinder, and ultimately the combustion product is leaving from the engine cylinder. So, to map the thermodynamic properties, we need to consider one cycle. In a SI engine, in general SI engines are based on the Otto cycle, rather all the thermodynamic properties are compared using an air standard cycle that we will discuss, and that cycle is known as Otto cycle. Whereas, in case of a CI engine, the change of thermodynamic properties during the entire process, during the cyclic process are compared, rather are mapped in a thermodynamic plane using a diesel cycle. So, the CI engine are based on diesel cycle. Now, number 2 is introduction of fuel. So, we are trying to figure out the fundamental difference based on certain points, certain factors. The first one, the first point which is considered to compare, that is a basic cycle. Second point which is considered to compare, rather to figure out fundamental difference between these two types of engines, is the introduction of fuel. And if we try to recall the schematic, where we have seen that in a SI engine the fuel is introduced through the carburetor, fuel is not introduced separately to the engine cylinder, rather the fuel air mixture is introduced into the cylinder, of course after passing them through a special component which is known as carburetor. So, I can write fuel and air, rather homogeneous mixture of fuel air are introduced into the chamber as a gaseous mixture, and for that a carburetor is necessary to provide the mixture. Rather homogeneous mixture we will discuss in detail, but in case of a CI engine, air is taken to the cylinder through air intake manifold, while fuel is taken through the fuel. So, here fuel is introduced directly to the cylinder through the nozzle, and air is taken through intake manifold. So, based on these 2 points we have classified, rather we have tried to find out the fundamental difference. And another important point is number 3, this is ignition. That again it is not required to say here, because we have seen to ignite the fuel air mixture, rather to initiate combustion of the charge in the cylinder, an external agent spark plug is there. So, spark plug is used for to initiate combustion, while for the CI engines the combustion, the thermodynamic state of the, rather pressure and temperature of the charged, the compressed charge is responsible to initiate combustion. There is no need of having an external agent like spark plug. So, the CI engine utilizes, I can write CI engine utilizes condition of high pressure and temperature of the compressed air to initiate combustion. So, that means in a CI engine, since we do not require to provide, rather install any external agent like spark plug, the engine utilizes the thermodynamic state of the compressed air at the end of the compression to initiate combustion. That means, the pressure and temperature developed of the compressed air, rather of air at the end of the compression is good enough to initiate combustion in the CI engine. So, these 3 are the different points based on which we have tried to find out the fundamental difference. There are another 2 important points. Number 4 is the compression ratio, which is known as CR. For SI engine we will discuss again in detail that for SI engine compression ratio is not very high. So, it is CR is typically 5 to 10.5, but for SI engine for CI engine. So, for SI engine compression ratio is not very high, it is typically 5 to 10.5, for CI engine it is 12 to 20. And finally, final point is weight. So, we also can differentiate fundamentally CI and SI engine based on the weight. I will discuss that since the compression ratio is not very high, that means it is an indicative measure of the strength of the pressure that is being developed at the end of the compression stroke. So, the lower compression ratio means the pressure developed at the end of the compression stroke is not sufficiently high, but since the CI engine, the CI engines are utilizing the high pressure and temperature of the air at the end of the compression stroke to initiate combustion, it is natural that the pressure developed at the compression stroke should be sufficiently high. Now, to withstand that sufficient pressure, I said that the piston rings are provided not only to prevent lubrication, not only to prevent piston from frictional effect, but also to seal the pressure within the cylinder because there should not be any leakage. So, the pressure which is being developed at the end of the compression stroke for the CI engines is very high. Now, to withstand that high pressure, the cylinder wall should be thicker as compared to the thickness of the SI engine cylinder. Now, since the walls of the cylinder will be thicker, naturally weight will be high. So, SI engine weight of SI engines are relatively low, and weight of CI engines are more. So, when we talk about weight is low for SI engine, weight is high for CI engine, but we have tried to find out why the weight should be higher for the CI engine, because we are utilizing the high pressure condition of the air at the end of the compression stroke to initiate combustion. So, we need to ensure the pressure which will be developed at the end of the compression stroke should be sufficiently high to initiate combustion, and while you are ensuring that the pressure developed at the end of the compression stroke will be sufficiently high, the cylinder will be acting like a pressure vessel. So, the pressure the cylinder needs to withstand, the cylinder wall needs to withstand the pressure, and as a result the thickness of the walls of the engine cylinder will be thicker, and which will eventually results in a higher weight. So, we have understood that fundamentally we can differentiate SI and CI engine based on these 5 points. So, today we have to summarize today's discussion, what we can say that we have understood different parts of the internal combustion engine. If it is SI engine, then carburetor is there, spark plug is there. If it is CI engine, carburetor will not be there and the spark plug will be replaced by the fuel nozzle, and then we have tried to explain that internal combustion engine can be classified based on the types of combustion and types of strokes. When we talk about the classification based on the types of combustion, and then we have seen there are 2 types of IC engines, internal combustion engines, one is SI and another is CI, and then we have tried to find out the fundamental difference between these 2 types of engine based on a few points. With this I stop my discussion today, and we will continue in the next class. Thank you.